Okay, so we continue our class vector analysis. Okay, today we come to the main topics of our course. Okay, before that, let's consider one problem here. Okay, so now I will consider a portion of a smooth curve in the space. Okay, let be a portion of smooth curve in space here. I denote it as C. Okay, let be C, capital C, and this C is a portion of the curve in the space. So from this C, we have 2 points. Let be this point be a initial point. Okay, I will denote as P. Of course, the initial point will be at T equals to some number. Let be some number A. And then we have a second point. Let be the second point is terminal point. Okay, let denote terminal point as Q. Of course, this terminal point at some value of T. Let be T equals to B. Okay. So now we have a portion of curve in space with 2 points. P here let be an initial point, and Q will be our terminal point. Okay, now from this C, we can find the parametric equation. So parametric equation of C, since C in a space, we will have X, Y, Z. So let be, this one is a parametric equation of C. So how to find the parametric equation of C? Meaning that you need to find X, Y, Z, where X here is given by a single variable function depend on T. Same with the Y. Y is equals to some function, single variable function depend on T, and Z also is equals to some single variable function which depend on T. Of course, the value of T is in between A and B. And the value of A and B here is depend on the initial point and also terminal point in C. Okay, so this one. So therefore, this part here we call it as a parametric equation of C. Then, after we find the parametric equation of C, we can define vector value function on C. What is a vector value function? Meaning that we can define our RT. Okay, RT. So RT here is a vector value function. When RT here is a vector value function, meaning that RT here will be in the vector form. So we have an I component, J component, and also K component. So how we can define RT on C? So at the I component here, we just take XT here. So XTR plus, okay, at the J component we will have YT, and then plus, at the K component here we will have ZT. Okay, so this one. So this RT is defined on C, where RT here is equal to XTI plus YTJ and then plus ZTK. Where I can find my XT, YT and ZT. XT, YT and ZT here is from the parametric equation of C. Therefore, we can define our vector value function on C by this form. Okay, now today we want to discuss how we can find the length of C. Okay, the length of C. So how we can calculate the length of C? Where just now we say that our C is a portion of a smooth curve in a space. C here, why I can say that when we discuss about C in a space can be line or can be a smooth curve. Okay, so how we can calculate the length of C? Length of C can be calculated by this formula. So now the length of C is equals to integration of magnitude of R prime T. Okay, and then with respect to dt. Since this integration with respect to t, meaning that you need to find the limit of integration here. Okay, the limit of integration here with respect to t. So therefore, the limit of integration here from a to b. So this limit of integration here is from the parametric equation of our C. So this is the formula how we can calculate the length of C. Okay, let's consider first example. Okay, let be our C is defined by this vector valued function RT 2 cos ti plus 2 sin tj, and then plus square root of 5t. Now from this example we need to find the length of C. Okay, the length of C. Okay, so given that our C is defined by this RT, then we want to find the length of C. How to find the length of C is given by this formula. Okay, meaning that you need to find the integration. You need to integrate the magnitude of R prime T, K dt, okay, with this limit of integration. Oh, sorry. So we will have the T here in between 0 and pi. Okay, sorry, 0 and pi. Okay, so now we can calculate the length of C. Okay, since our C is already defined by RT, okay, so we have RT, meaning that in this formula we need to find only this one, magnitude of R prime T. Okay, what is the R prime T? So R prime T, actually this one is just you take the first derivative, you take the derivative of each component with respect to T. This derivative, and this derivative. So R prime T here is equals to, okay, this derivative we have 2 sin T I, and then plus, take the second derivative here, 2 cos t j, and then plus square root of 5k. Okay, and then after that you just find the magnitude of r prime t. What is the magnitude of r prime t? Okay, so this one is just a square root. Okay, so you take the square here, so you will have 4 sine squared t, and then plus 4 cos squared t, then plus, okay, this square root of 5 here, you will have 5. Okay, so the last one you will have, okay, so this identity you will have 4 plus 5, you take the square root of 9, so in the end you will have 3. Okay, the value here is 3. Okay, so next, you want to find the length of C, meaning that you just need to use this formula. Okay, you already calculated this one, magnitude of r prime t, therefore this one, r prime t is equals to 3, and then you have dt. So how about the limit of integration here? The limit of integration here, you need to take from this one, okay, from your rt. So this one, t starting from 0 until pi. So in the end, you have the answer is equals to 3 pi. Okay, so 3 pi is the length of our C. Okay. Okay. So let's consider next example. Example number 2. Okay, let me my C. Okay, C is defined by y is equals to x squared in the xy plane. XY plane from point 0, 0 to 2, 4. Okay. Then find the length of C. Find the length of C. Okay, so now example number 2. So now we have C. C here is the y is equals to x squared in the xy plane. Okay, what the meaning of xy plane? Meaning xy plane, your z here is equals to 0. Okay, of course, this y equals to x squared, we consider a portion. Okay, a portion where from point 0, 0 to 2, 4. Okay, meaning that if you draw this y equals to x squared, what is the y equals to x squared? Y is equals to x squared is a parabola. Okay, y is equals to x squared is parabola. But now you only consider a portion of parabola from point 0, 0 to 2, 4. Meaning that you have 0, 0, and then you have 2, 4 somewhere here. Okay, 0, 0, and then you have 2, 4. Okay. So this one will be this one will be our C. Okay, just a portion of our parabola. Okay, so now we want to find the length of C. Okay, this C, we want to find the length here. So by the formula, L, okay, let's denote the capital L as the length of C. So this L by the formula is just a integration of magnitude of R prime T dt, and then of course my T, the limit of integration will be from A to B, okay, some number A to B, okay. So this is the formula. Okay, of course from this second example you don't have RT, okay, you don't have RT, meaning that if you don't have RT, next the first thing you need to find RT for this C. You need to find RT defined on C. Okay, how to find the RT? First thing, you need to find the parametric equation of C. So C, the parametric equation, okay, since we consider C in the space, we have X, Y, Z. But we already know our C in the XY plane. What the meaning of our C in the XY plane? Z equals to 0, meaning that Z is equals to 0. So now you need to find your X and Y. So how to find the parametric equation for the parabola? So this one we already discussed in the first week of our course. So to find the parametric equation of parabola, X is equals to T. Then since Y is equals to X squared, from here Y is equals to T squared. If you forgot, then you need to recall back how to find the parametric equation of parabola. Okay, now we have this one, and then we need to find the value of T. Okay, the value of T here should be in between some number. So from this point, X equals to 0, Y equals to 0. X equals to 2, Y equals to 4. So from how to get, okay, so here X equals to 0, meaning that our T should be equals to 0. And then our X here equals to 2. X equals to 2, meaning that our T is equals to 2. Okay, this one. Of course, it should be follow the value of Y, meaning that if X equals to 0, T equals to 0. So from here, T also equals to 0, T also equals to 0, Y is equals to 0. Okay, it's correct. T here should be start from equals to 0. When T equals to 2, because this X equals to 2, T equals to 2, 2 squared is equals to 4. Okay, you have 2, 4. So it's coincide also for X and Y. So the value of T in between 0 and 2 here is correct. Okay, so this one. Okay, after you find C, then you need to define, or you need to find your RT. Okay, what is my RT? So I will have I, J, and K. For I component, we take this one, Ti, and then plus this one, T squared J. Of course, Z equals to 0. 0 times K is 0. So I will have this RT, Ti plus T squared J. So after we found our T, from this definition we need to find R prime T. What is my R prime T? So for that, R prime T. What is my R prime T? So I prime t, we take just the first derivative of t, this one. So derivative of t is 1. So I have I plus this derivative, I will have 2t j. So this one. Okay. So next, after you find the r prime t, you need to find the magnitude of r prime t. How to find the magnitude of r prime t? You just take the square root. Okay, so this one 1 squared and then plus 4t squared. Okay, so the final answer will be 1 plus 4t squared. Oh, sorry. The magnitude of r prime t is equals to this one, 1 plus 4t squared. Okay, after that you just substitute to this formula. So r prime t here will give us 1 plus 4t squared. And then I will have dt. So my t here is between what? From the parametric equation of C, our t here from 0 until 2. Therefore, the limit of integration here from 0 until 2. Okay. So from this one, I just leave it for you to calculate this integration. Okay. I would like to ask you to recall back how to calculate the integration of this function. So the final one, you will get the answer, the final answer. This final answer will be the length of C in the example number 2. Okay. Okay, you can calculate this one. Okay, let me, this one is your home task. Okay, try to finalize this calculation. Okay, you will get the final answer. Okay. Okay, so next we will come to the main topic. Okay, one of the main topics in our course. So now today we want to discuss about line integral. Okay, line integral. Okay, so first let us discuss what's the definition of line integral here. Line integral is an integral of function f(x,y,z). Okay, so we consider general function here, which means this function here depend on 3 variables x, y, and z over curve C. Okay, over curve C, where C here is just a curve in the space, line or curve in the space. Okay, such of integration of integral of function over C. So this one we call it as a line integral, and we denote the line integral here as this one. So now we have a single integration here, and then I will have this function f(x,y,z). Okay, and then I will have ds, okay, small s, and then this limit of integration should be respect to curve C. Okay, so such of notation here we call it as a line integral. Okay, we denote it as a line integral. Okay, so now we have C over C. Okay, before that, let's discuss what the meaning of ds here. Okay, ds. Okay, I just want to recall from your previous calculus, cos, when you consider such of integration of fx dx. Okay, fx dx. What the meaning of dx? Dx is represent the small length, right? Okay, meaning what the meaning of this integration here? Meaning that this integration, okay, you integrate this function here along x-axis. Okay, if you remember, along x-axis here. So meaning that you have this function, and then you will integrate this function along x-axis. Then this dx here is referred to the small length. Okay, small length at the, okay, we refer to the small length along x-axis. Okay, dx here. Actually, dx is from where? How we can get this x here? This x here is actually is just dx here is actually when you consider delta x is approach to 0. Delta x is referred to the small length, okay, along x-axis. When it approach to 0, then it will become dx. Okay, so therefore when you have a dx, and then you take the summation of all dx along this x-axis between these two values, then you will have this integration. Okay, where actually integration here comes from the summation. If you remember from the previous calculus, from the summation where you take the limit here goes to infinity. As the limit here goes to infinity, then this delta x here become very small and very small. Okay, it will approach to 0. This delta x, when you approach to 0, it will represent as the dx. Okay, so this is the meaning of dx. Okay, same thing. When you consider of ds, what do you mean of ds here? ds meaning that if you consider a c in the xy in the space, okay, so ds will represent the small length, okay, the small length along c, okay, the small length along c, okay. So it's just the same thing with dx. The different dx you consider a small length along x-axis, but for ds you consider a small length along c. Okay, of course when we take the summation here, okay, the limit of summation goes to infinity. ds, okay, actually ds is from delta s approaching to 0. Of course, when you take the summation goes to infinity, then our delta s here will become very small and approach to 0. When delta s is approach to 0, so this delta s can represent by ds. Okay, so ds here, like I said just now, is just a small length. Okay, small length along c. It's just the same thing with dx. The difference here, dx on the x-axis, ds is along c in the space. Okay, so now this is a line integral. So how we can calculate the line integral here? So line integral is the integral of this function over c. Okay, by the definition, this line integral can be calculated by this formula. So this one is actually is equals to f xt yt zt. Okay, and then you need to times with the r magnitude of r prime t dt. Okay, of course now the limit of integration here with respect to t So this t should be in between these two numbers. T equals to A, t equals to B. Okay, so now x we have xt, y we have yt, z we have a zt. So where we can get my xt, yt and zt? Xt, yt and zt here is from the parametric equation of C. Of course, after you find the parametric equation of C, then you will have xt, yt, zt, then you can find the magnitude of r prime t. Of course, when you find the parametric equation of C, you will have this value. You know the value of t here between these two numbers, A and B. So therefore, you can compute this line integral. Okay, line integral. Okay, so this is the definition of line integral, or the formula how we can calculate the line integral. Okay, let's consider example. Example number 3. Okay, so let's evaluate this integral. Okay, evaluate the line integral. Evaluate this line integral. Okay, C x plus y plus z and then ds, where C is the line segment from these 2 points. Okay, from 1, 2, 3 to 0, minus 1. Okay, so this one. Okay, example number 3. So we want to find this integral. Okay, where the integral of this function over C. Okay, what is our C? C is the line segment from 1 to 3 to this point, 0, minus 1, 1. Okay, meaning that we want to evaluate the line integral. Okay, so we will have a line integral. Okay, so okay, so I just some part here. Okay, first let's write the formula of line integral. The formula of line integral, C, so x plus y plus z ds. Okay, sorry, let be general first. Okay, so I will have x, y, z. So this one is equals to what? So this one is equals to the integration of, so now I will have xt, yt, and also zt Okay, so this one. And then I will have magnitude of r prime t. Okay, and then I will have dt. Okay, so this is the definition of line integral. Okay, so now we just need to find the whole thing here. So do you have a xt, yt and zt? So we don't have, meaning that we need to find what is our xt, what is our yt, and what is our zt. So how to find this xt, yt and zt? We need to find the parametric equation of our c. So what is the parametric equation of our c? So since c is the line segment from 1 to 3 to 0, -1, 1. So now I will have c is equals to x0 plus x1 minus x0t. Y is equals to y0 plus y1 minus y0t. Then z is equals to z0 plus z1 minus z0t. So this is the formula of parametric equation of our line segment. Okay, so x0, y0, z0 is from the initial point. So I will have 1, 2, 3. So this one I will have 1, 2, 3. So what is my x1, y1, z1? x1 is from y1, z1 is from the terminal. So this one will give me 0, -1 and 1. So this one will be 1, 2, 3. Okay, so I will have 1, 2, 3. So final answer I will have 1 minus t, 2 minus 3t, and then this one will give me 3 minus 2t. Okay, 3 minus 2t. Okay, of course, my t here, okay, since this one is just a line segment, my t here will take from value 0 until 1. Okay, so this one. So this is my parametric equation of, so this is the parametric equation of C. Okay, then after that, from this parametric equation, I can find my RT. What will be my RT? Sorry, not RT. Okay, what will be my RT? So RT is equals to 1 minus t r, and then plus 2 minus 3 t j, and then plus, okay, this one that 3 minus 2t. Okay, so this one 3 minus 2t. Okay, so this is my RT. So this one xt, this one will be my yt, and this one will be my zt. This one. So after I found my after I find my RT, I can find my R prime t. What is my R prime t? I just take the derivative. This derivative, okay, minus r. This derivative minus 3j, and then this derivative will be minus 2k. Okay, so this one. And then I can find the magnitude of my R prime t. So magnitude of my R prime t will be square root 1. Okay, so this one should be minus 1 squared plus minus 3 squared, and then plus minus 2 squared. So the final answer will be 1 plus 9, and then plus 4. 1 plus 9 plus 4 will be square root 40. Is it? Okay, square root 40. So this one, square root of t, is the magnitude of R prime t. So this one will be square root of 40. Okay, square root of 14. Okay, this one. Okay, of course, my t. So the limit of integration, my t. So from the parametric equation, my t here between 0 and 1. So this one should be 0 until 1. Okay, the limit of integration. Okay, so now we need to find this part. What is my f x t y? What is f x t y t z t? Okay, so from here. Okay, so my f x y z is equals to x plus y plus z. So from here, so what is my xt? My xt is 1 minus t. What is my yt? Yt 2 minus 3t. And then what is my z? Zt is will be 3 minus 2t. So this one. Meaning that my x here you need to substitute with 1 minus t, y you need to substitute with 2 minus 3t, z you need to substitute with 3 minus 2t. So from here I will have 1 minus t plus 2 minus 3t and then plus 3 minus 2t. So final one we will have what? 1 plus 2 plus 3. 1 plus 2 plus 3 will be 6. Minus t minus 40 minus 60. Okay, so this one minus 60. So this one will be 6 minus 60 for this one. So therefore you just substitute this one. So this one will be 6 minus 60. Okay, should be in bracket. Okay, because of what? Because the whole thing here should be times with this magnitude of r prime t. Meaning that you will have this bracket 6 minus 60 and then times with square root 14. So since this one is just a constant, you can put outside. So square root of 14. Okay, so we integrate this one with respect to t. So I will have 6t minus 3 squared. And then this one t equals to 0, t equals to 1. Then the last one, the last answer, I will have, okay, 6 minus 3. So I will have 3 square root of 40. Okay, so this one. Okay, so this is the value of your line integral. Okay. Okay, let's consider the last example. Example number 4. Okay, example number 4. Okay, let's evaluate this one. So let's evaluate this integral. Okay, so I will have x squared over y. Okay, let be x squared over y. Okay, ds, and then I will have c. Okay, where c is y is equals to x squared over 2. Okay, with x here in between 0 and 2. Okay, this one. Okay, C here is in the xy plane. Okay, C here is in the xy plane. Okay, let's try to consider fourth example. So now we want to integrate. Okay, we want to integrate this line integral x3 over y over c, where c is y is equals to x squared over 2 with x in between 0 and 2. Okay, this one. Okay, so we consider C in the xy plane. Okay, C in the xy plane. So meaning that our z here is equals to 0. Okay, so first, okay, let's write the definition. Okay, so the formula of line integral. So I will have C f x y z ds. Okay, so this line integral is given by this formula. So I will have f x t y t z t, and then the magnitude of r prime t, and I have dt. So this t, the limit here should be in between a and b. Okay, of course you need to find the whole thing here. Okay, so now what is our xt, yt and zt? Do you have or not? Okay, so we don't have our xt, yt and zt, meaning that we need to find our xt, yt and zt. Xt, yt and zt is from the parametric equation of our C. So now my C is the parametric equation. So x, y and z here. So since my C in the xy plane, what the meaning of C is in the xy plane, meaning that our z here is equals to 0. So from here I will have z is equals to 0. Okay, and then I will have x and y. So this one is just a parabola. Okay, parabola. So this portion of parabola, so you can find the parametric equation of parabola, meaning that our x is equals to t. Then my y, so I will have t squared over 2, meaning that I just substitute x equals to t here. So I will have t squared over 2. Okay. Of course, my t here in between which value? So my x here in between 0 and 2. Of course, x equals to t. T also will be between 0 and 2. So t is between 0 and 2. Okay. So I will have my parametric equation of my C. Okay, and then now from here I can find my RT. What is my RT? So RT, okay, is equals to XTI plus YTJ plus ZTK. What is my XT? My xt is t, I, and then plus yt, t squared over 2, okay, j. Okay, of course my z equals to 0, 0 times k equals to 0, so I will have this one. So from here, I can calculate my r prime t. What is my r prime t? Okay, we take the derivative of t, so I will have I plus, okay, t, j. Then I can calculate my r prime t, magnitude of r prime t. So this one will be square root of 1 plus t squared. Okay, this one. Okay. So therefore, this part will become square root of 1 plus t squared dt. Okay. Okay, now you need to find this one. F, x, t, y, t, z, t. How to find this one? So what is our function? Okay, I can write f x y z. Our function here is x3 over y. Okay, x3 over y. Yeah, x3 over y. Okay, x3 over y. Okay, so since my function here doesn't depend on z, okay, it's okay. Let be x3 over y. So from here, I need to calculate. I need to find this one. What is my xt? My xt is equals to t. What is my yt? My yt is equals to t squared over 2. What is my z? My z here is equals to 0. Okay, so it's fine. So meaning that x equals to t, y is equals to t squared over 2, and this one is 0. Okay, you just substitute. So x3, x is equals to 3, t. So I will have t power of 3, and then my y here will be t squared over 2. So this one, I just substitute t squared over 2. So the final one, I will have, okay, 2. So I will have 2t. So this one I will have only 2t. Okay, so therefore this one I will have 2t. Okay, I will have 2t. Okay, of course the limit of integration here, t, okay, from the parametric equation our t from 0 until 2, is it? So from here t equals to 0, t equals to 2. Okay, so you only have this one. This one. Okay. So this one, of course, you can integrate this one by yourself. You can calculate this one. If you forgot, meaning that you need to recall back how to calculate this integration here. And then the last one, you get the final answer. So the final answer here will be the value of this integration. Okay, line integral. Okay, so you can calculate this one. Of course, the important thing here, I just want to show you. Okay, the first thing I want to discuss with you what the meaning of the line integral, and the second, you need to know how to calculate the line integral. So line integral, we have this formula, and then you need to know how to find for each term in that formula. Okay, meaning that you need to know how to find the limit of integration here, and then you need to know how to find the fxt, yt, zt, and then you need to know how to find the magnitude of r prime t. Okay, after you found the whole thing here, okay, so you can just substitute into this formula, and then you can just integrate as usual. This one is just a single integration, and then you get the final answer. Of course, always remember the line integral here is always depend on the parametric equation of your C. Okay, always remember the line integral is always related to the parametric equation of C. So meaning that if your C here doesn't given any parametric equation, meaning that you need to find this parametric equation first. Okay, after you find the parametric equation of C, you find your xt, yt, zt, then you can find the rt, and then after rt, you can calculate the r prime t, and then you can calculate the magnitude of r prime t, and of course you also can find the fxt, yt, and fxt, yt, zt. Okay, and then you just substitute into the formula. Okay, and then the final one you can calculate, and then you get the answer. Of course, the limit of integration here also should be on t. Okay, depend on t, meaning that this limit of integration also relate to the parametric equation of C. Okay, so okay, you can just finish this calculation. You can get the answer, the final answer. Okay, now let's consider the fifth example, and that be fifth example here be your home task. Okay, you can try to do by yourself. Okay, no need to submit this solution, this answer. Okay, let be the example number 5. Okay, so let be this one is your home task. Okay, so okay, let's see here is the portion of this curve in the xy plane. Okay, let be x squared plus y squared is equals to 4. Okay, of course this one, okay, x squared, let me see, is the portion of x squared plus y squared is equals to 4 at the first quadrant. First quadrant, the xy plane. Okay, from this point, okay, from point to 0 to from 0 to square root of 2, square root of 2. Okay, so this one. Okay. Okay, then, okay, first find the length of C. Okay, first to find the length of C, and then the second one, evaluate this integral. Okay, evaluate this integral. Okay, this integral. Okay, of course this one is just a line integral. Okay, because of what? Because you have a function here and then you integrate this function over C. Okay. Okay. So let be this one is your last example. Let be this one is your home task. You can try to do by yourself. Okay, if you feel that you still need more exercise for this topic, then I will suggest you to do more exercise in the Thomas calculus. Okay, Thomas calculus book. So in the Thomas calculus they have a lot of exercise on this topic, or maybe you can find another exercise in online. Okay, in online, maybe you can try to do this exercise. Okay. Okay. So I will finish my my class today, and then we will consider the next topic. We'll discuss on surface area and also surface integral. Okay, surface area and surface integral. Okay, of course you need to recall back how to find the parametric equation of surface. Okay, this one we already discussed in the first week of our course, so you need to recall back. Okay. Okay, so that's all. Okay, thank you.